Well, hello and welcome to this week's edition of the City Update. I'm your host, Mark Aaron, Multimedia Design Manager for the City of Danville. Today we're out on the campus of the Institute for Advanced Learning and Research at the Haas Center for Advanced Manufacturing, and we're here with Troy Simpson, who heads up the Advanced Manufacturing for Danville Community College and is also partnering with the Institute for Advanced Learning and Research. And just last week, as of this taping, we had, of course, the ribbon cutting ceremony for the Integrated Machining Haas Center here at the Institute for Advanced Learning and Research. And on today's show, I wanted to dive a little bit deeper and talk about this capstone program. The third year of this advanced manufacturing program at DCC that's going to be housed here at the Institute, give you a better understanding of that program and also give you an up-close look at some of the machining that's going to be utilized by students here at the Institute. So Troy, I really appreciate you taking the time to join us today. I know you're a busy man, and I appreciate you taking the time to talk a little bit about this program. And I know a couple of years back, we went over to DCC, talked to some of your students about precision machining, and just over the last decade, it's amazing just how far precision machining has come and really the demand for your students in the workplace. Can you talk a little bit? I know you've been with Danville Community College, for almost 25 years.
Yeah.
So tell me a little bit about precision machining and how far it's come over the last decade and a half.
Yes, for sure. You know, if you look back to 1991, when I started working at Danville Community College, my work colleague Doug Poole and I come in 91. He was new in 92, and in that area we had about 15 students in machining, and we're really focused on turning the program around where we could develop the curriculum and get equipment in place so that employers in our region could hire students with the skill sets that they need. And so if you fast forward from 1991 to today, it's been a vision of many people in our community, many team players to get us to this point. What has actually evolved here is that over the years, manufacturing has definitely changed, and the skill sets that's required of those students who's coming out of this program has changed as well. Back in 91, you know, a lot of manufacturers were looking for people with fundamental machining skill sets, and we're very pleased to get them. And so as the program started to evolve and more students started to enroll and manufacturers were looking for these types of students, we had two things that kind of happened simultaneous. The technology was changing very rapidly, and also the manufacturers were recruiting and trying to hire more students than we actually had enrolled in the program. And so we went through several years there where students were getting multiple job offers, and students were also in such high demand that we reached enrollment caps. So we had a capacity of about 52 students. We could take 26 freshmen each year in a 2-year program, and then we got to the point of having a wait list, and then we still were having students getting multiple job offers, but the sad fact of the matter was we still had jobs unfilled and very high paying jobs, but not enough students graduating to fill those jobs. And so what we embarked on many years ago was to look at a way that we could grow the capacity of the program, but also the capability of the program. Because as we said, as the manufacturing technology started to change, the manufacturers were looking for students even with higher skill levels that got into the computerized numerical control programming and operation, the metrology department such as coordinate measure machine program and operation. And so to be able to do that, we knew that one, we had to have more space. Two, to increase the capability and capacity, especially capacity, we need to hire more instructors, and we would have to bring on literally millions of dollars worth of equipment to give our students an opportunity to be trained on very advanced technological equipment, but to make the environment to which in the labs where the students had their own individual machine tool to set up and operate versus it being a theory-based program with one machine and 26 students. So our goal was to have 26 freshmen and move that to 52, the capacity to handle 52 freshmen, and that every day that the students in that lab, they can operate their own CNC machine tool, and some of these machines cost $80,000 a piece. So we knew it would take a huge investment. So 4 years ago, as the program grew, we started to reach out to our community leaders and elected officials and brought basically the whole community together and shared the vision with them and to explain to them how this would provide a lot of opportunity for students, but we also felt like it give us a huge advantage in economic development because across this country you see very few machining programs that has this capacity nor this capability. So thanks to many partners over the last 4 years, such as the Danville Regional Foundation, who has invested heavily in this program. We've been awarded some Department of Labor TACTA grant to help fund the program. Partners such as Haas Automation, who has invested heavily. You'll see equipment some today in the show, some equipment that Haas is providing for us, and putting that equipment in place and exchanging that equipment every 24 months to make sure the equipment stays relevant and current. They've also awarded us $1 million, wrote us a check for $1 million to help support the program. And we have other companies like Sandvik Coromant, global leaders in tooling and technology, that are very heavily involved. You'll see as you walk through this lab, you will see tooling in place. You'll see yellow cabinets here that represent Sandvik Coromant, that are providing application engineering support, tooling for these machine tools to run, and actual training materials and curriculum so that our students get some real high-end training in tooling applications. And then we have another great partner in technology partner, Midatoya, which is a metrology solutions company, have heavily invested in this program, are very involved in curriculum development. And then we have great industrial partners. So if you look at, we have such as we have Piedmont Precision, we have North American Mold Technology, Babcock & Wilcox in Lynchburg, Schrader Bridgeport and Alta Vista, friends to our south as well. So if you look at how we've got to this point, Mark, it really boils down to it's been a team effort of many industrialist technology companies, leaders in the community, the college president, the executive director, Mr. Gwaltney at the Institute. I hesitate to mention names, but because there's so many people has been involved to get us to this point. This third-year program that we've just started is a really unique model. It's the first of its type in North America that we have seen. We reached out to industrialists and says, what do you need in an advanced trained student who will come into your shop floor, your factory, and be able to understand all of this new technology and the acumen of how it all works together, and to understand the culture of organizations as while it's important to be productive and important to be profitable so that these companies can remain in our region. So what you see here is after all of this dialogue and all of these meetings is this third-year Integrated Machining Technology program is a program that allows our students who can actually get involved in precision machining at the high school level. So Pittsylvania County, about 2 years ago, there was over $1 million investment made in that program to where students can get involved in this curriculum in the high school level, junior and senior year. Right. Through dual enrollment, earn about 40 college credits, and then transfer to DCC, which is an 80 credit hour 2-year program, and already have the first year of that instruction behind them through dual enrollment. Finish the DCC 2-year program in 1 year and transfer to what we call the Integrated Machining Technology program, the capstone model, which is a third-year program, but it's only that second year of college. Right. So we've been able to put programs in place at the high school to help them fast track, help them decide on a career path, get involved in the high school, and elevate all the way to a very advanced program.
Talk a little bit about this advanced program, that third year. How will it benefit your students versus what they were able to do just 12 months ago?
Yeah, the third year program, what's so exciting about it is it will give these students an opportunity to learn not only the setup and operation and program machine tools, but all the IT integration, because there's so much now the technology that's going on inside the machine tools, such as in-process inspection, programming macros, how the parts should flow from one machine to the other, how to set up a lean flow cell environment to where in manufacturing now, there's some of the top manufacturing companies in the country are really setting their shops up like what you see here in a flow cell environment. And many people have asked, what is a flow cell? Yeah. Well, a flow cell is really nothing as far as the theory behind flowing parts through a very organized and a very coordinated process, but it's all about the students understanding how to work together in a team environment and so that the part flows from one machine to the next machine to the final product. So that it increases throughput time, decreases inventory, decreases waste, and makes a company more profitable where they can compete on a global stage. So the students will get, like I said, not only the hard skills, but they're also learning managerial skills. Right. And and organizational behavior and manufacturing economics. And so this program is really designed for that student who wants to go out in manufacturing and be impactful day one, to understand why manufacturers manufacture the way they do, and to align themselves and give them the skills they need to become future leaders in manufacturing. So the whole concept here is that we're not saying a student goes out day one and becomes a manufacturing manager, but we're giving them the tools they need to become a manager and to become a frontline manager on the shop floor, and give them the tools they need. You know, students in these programs can typically start out in manufacturing, and many of our past graduates have worked all the way up through, get their engineering degree, and become engineering managers in manufacturing plants. So as we've told them many times before, if you want to become a plant manager, you can get started here. You can go to work in manufacturing. You can go back and continue education throughout your career, but there's nothing to stop you from becoming the lead in a manufacturing plant.
That is great. Now, you've got your first class that will be taking part in the capstone program starting this fall, correct? And
yes,
they'll
sir.
graduate in the spring from that third-year program, right?
Yes, we have graduates right now who have committed to the program, who just graduated in May from Danville Community College out of the 2-year program coming here. We also have graduates from Whitfield Community College up in Southwest Virginia. They have a 2-year machining program who have committed to transferring here to the third-year program. And we've also had students who graduated in years past out of our program have contacted us wanting to enroll in this program. We actually have 2 guys today coming by this afternoon that are past graduates that want to see how they can work this into their work schedule to come back and get this third level experience. So we see it's touching many different lives, and it's appealing to many different individuals, whether they be current students, past students, or incumbent workers.
Great. Now let's talk a little bit about what is actually made. When we talk about precision machining, we know we have Virginia Mold Technology here. We've got Piedmont Precision, the companies just locally here. But can you talk, I know these are, they're not making particular parts that would be used that will be made at these companies, but can you talk about some real world experience and what is actually made when you talk about advanced manufacturing, integrated machining?
Well, I think if you look at advanced manufacturing, it's, at times people have a hard time understanding what is advanced manufacturing. Yeah. And I know I had an executive with Rolls-Royce one time, and we were talking about what is advanced manufacturing. And he best defined it, and he said, advanced manufacturing is a company who makes a highly valued product, who spends millions of dollars on research and development, a highly precise product that is a high consequence product. So typically if you look at advanced manufacturing, like we view advanced manufacturing, it's parts that are highly sophisticated. It takes highly technical machine tools, highly technical technicians to control the process, and at the end of the day, it's a highly valued product. So if we were making, you know, plastic containers, there's some very advanced technology in that operation, but here it's advanced technology in operation, but it's also a very highly valued, high consequence part. So a student out of this program may go to work for an aerospace company who's machining a $150,000 component, or they may go to work for a nuclear energy company such as Babcock and Wilcox and Lynchburg that's making power plants for submarines and aircraft carriers, and it may be a multi-million-dollar component that person is working on. So that the types of components that the students will learn to make here is it gives them an opportunity to make similar operations. It's not that we make that rotative disc for a jet engine, right, but there's technology and processes that they can learn in here that is applicable to that manufacturing application. So when you walk in here and see what the students will be doing, it's complex parts that's produced on multi-axis machine tools that requires extreme skill sets to be able to design those parts, write programs to set the machines up to make them, and then go in the metrology lab and to validate part quality.
Wow, very good. Well, it's just amazing how far you all have come just in the last 25 years, and then just the last 4 years when it comes to the amount of money that not only the state, locality has put towards this program, to see it grow and just see the importance of having this advanced manufacturing here in our community when it comes to economic development, but also for the students as well, some high-paying jobs for these individuals when they graduate from this program.
Yeah, it really is. If you really think about it too, and I said if you look at the value proposition for the parent, you know, we have a lot of students that come through this program in 2 years. They go through a Danville Community College 80 credit hour program, you know, $10,000 investment in a career 2 years later, they're 20 years old, walk out, many of them land jobs $50,000 or above starting pay. And 2 and 3 years into that career, with the amount of overtime that a lot of these students are working, it's not uncommon to talk to students who are making $80,000, $90,000, $100,000 a year, and they're 21, 22 years old, and they've invested $10,000 in their education. So as a parent myself, this proposition looks really nice. And many people ask, well, you know, why do these career sets pay? Why are students getting these kind of offers? And really, it boils down to this: skills. Manufacturers pay for skills, and they pay for those skills to people who can perform and add value to the organization. So I think that's really what kind of sets the program apart. I think our instructors are doing a really good job preparing these students for those jobs. And so we're very excited that the students can now take it to a next level, so that as the technology has changed and is changing, that they're embracing that change, and we can provide manufacturers with students who already have those skill sets, and they don't have to do all of that training after they employ that person.
Well, Troy, I really appreciate you taking the time to join us today and kind of explain a little more in detail about advanced manufacturing. And we are so excited here in the city of Danville and the Dan River region to have this program, see this programming continue to go. And one thing we didn't mention was with Gene Haas's support, these pieces of machinery, they're going to be updated. So as you know how electronics are and computer, everything, it changes day by day, but you're going to have state-of-the-art equipment in here for the foreseeable future, right?
Yeah, that's the value. That's one of the values that this partnership brings. Is as we said, the technology, it changes so rapidly. Yeah. It's so difficult for schools to stay on top of that curve just because of the expense. So as we've developed this partnership with them, and as our local Haas factory outlet in Greensboro, Virginia, which is in Greensboro, North Carolina, I'm sorry, Brooks Barwick, who is the president of Jeffries HFO, as we sat down and talked to him, you know, and that was something he was really willing to go to bat with Haas Automation in California, and said, you know, I'd be willing to support this program because I've never seen this type of program in North America at training at this level. And he said, so, you know, I would be willing to go to bat and just replace this equipment and trust it to you, and every 2 years take it out and give you another new piece. So you're looking at, you know, right in this lab alone, you're looking at over $600,000 of entrustment equipment that will be going out of here in 24 months and 4 new pieces coming back in. So it's an amazing partnership.
And it's great to see that people across the country are seeing just how well we're operating here in the Dan River region and the importance of this program, and we're doing the right things right, and great to see that here. And Troy, we appreciate you taking the time to join us today, and maybe in the fall when kids start in the laboratory, we'll come back out and maybe talk to a couple of them, and then in the spring for graduation, I know they'll be heading off and they'll be getting jobs probably here in our region and maybe some outside as well. So we appreciate it. Thank you so much.
Thank you. I appreciate it.
We're going to take a quick break. When we come back from break, we are going to take a closer look at some of the pieces of equipment here at the Gene Haas Center for Integrated Machining. So stay tuned. We'll be right back.
Ballerina.
Sometimes all it takes to be a dad is remembering how to be a kid again. Take time to be a dad today.
We're now in the lab of the Gene Haas Center for Integrated Machining Technology, where the machine tools are set up in the flow cell that we talked about earlier. Some of the equipment that you'll find in here, for example, is a Haas VF3YT. This machine has a capability of doing 5-axis simultaneous milling. We would add another device to the machine table. As we see here, this machine is set up to machine multiple parts. Lots of technology in this machine, such as the infrared camera you see in the back, where we can do tool inspection and in-process gauging of machine tools. The next machine here, this is a very highly technical machine. This is the Haas UMC 750. This is a brand new machine that they're providing for us as well. This machine is a true 5-axis machine with a rotary table and trunnion integrated into the machine. So this machine tool, students will learn how to set up, operate, and program a true 5-axis multifunction machine tool. Then on this end, this is a turning center. Kind of an example of some of the parts that we produce on this machine. It's a turning center that actually we can mill inside this machine. So it's a multifunctional machine tool to where we actually can turn and mill and do auxiliary milling functions as well. So it's kind of the students get the opportunity to learn how to program and set up multi-axis machine tools. This machine is a Haas VF2 SS high-speed machine. Here we have Jeremiah Williams, the lead instructor in the third-year integrated machining program, is machining some pieces today in this machine. This machine is designed to machine very high-speed applications, highly productive. So these students who operate these machines will learn how to use highly productive, high-speed tooling in this machine at speeds and feeds and part production that they don't typically see in a typical community college environment. So this is a very, very high-end machine tool. Okay, what we have in this section of the lab, this is what we call CNC grinding. The first machine tool is a CNC surface grinder that the students will program to operate to grind highly precision parts with very fine surface finishes to extremely close tolerances. So that machine can grind profiles, form, and flatness. As the part moves to the next particular machining operation, this is the type part that would be produced here where we grind it flat on that machine. This machine, we would have an opportunity to grind the internal features of this part, like the bore and the outside of it. If you look in the machine, you have two different grinding wheels. One of those runs 20,000 RPM, the other spindles are 30,000 RPM, and we can hold down to about 1/10,000th of an inch as far as dimensional tolerances. So this is a very, very accurate machine, and it's used as a finishing operation in very sophisticated parts such as aerospace and medical. Then as we go down to the next machine, Mark, it's a machine tool that we grind the outside diameter parts. So this is considered an OD grinder, but it is also CNC controlled. Just to give you a little magnitude of the equipment here, these three machine tools that we just looked at is over a $400,000 investment in this program just in three machine tools, so that the students have an opportunity to learn to program, set up and operate machines that they would typically see in a manufacturing plant prior to going on the job. What we have here is a Mitsubishi electrical discharge machine that is called a wire CNC machine tool. This actual machine and the technology machines very precise parts using electrical current. So versus a conventional cutting tool like we use on a milling machine that you just saw or turning center, we actually shape the material here with electrical current removing material. So the students learn how to program that, the technology behind electrical discharge machining. Another EDM machine that we have is a CNC, what we call a sinker machine. This machine, versus using wire for a discharge, it uses a graphite electrode that we machine in a CNC milling machine, place in this machine, and actually erode away a feature in a part which is a mirror image of the electrode. So we're not turning metal into chips, we actually turn metal into, we burn that material away with electrical current and erode away the unwanted material to produce shapes that we can't typically produce on other machine technology. Okay, yeah, here at Danville Community College, a partnership between ILR and DCC, we have a very robust metrology lab as well. What metrology is a science of measurement. When we make very complex parts, we have to have a way to validate part quality. And in order to do that, it's a very highly technical, sophisticated equipment that is used to inspect these parts. For example, here we have a Mitutoyo coordinate measure machine. The part that you see here is actually a part that's made locally at Piedmont Precision. What this machine does is we actually set up and program this machine that measures the many different features of this part through this actual touch probe and touch trigger. So a student who can set up and operate this machine tool, this is a highly sought after skill set in manufacturing. Most advanced manufacturing companies will have this technology, and this is a very difficult individual to find who has these skill sets. So what we're going to do, in August, we're starting a new metrology program here in Danville. Students can enroll in this program starting in August. By enrolling in this program, they will learn the skill sets necessary to inspect highly sophisticated parts. If you notice here at the metrology lab at the Haas Center, we have multiple of these coordinate measure machines available for student training. Just like the machine we just looked at, here's another larger scale coordinate measure machine. If we look on around on this side, we also have 2 more of these 544 coordinate measure machines. So there's been a huge investment in technology here to provide students this opportunity. So students who enroll in the metrology program starting in August, they can go through as a 1-year certificate program. After 1 year, they should qualify for some very high-paying jobs in the science of measurement. If you also notice in here, very clean environment, atmospheric controlled. So in the world of metrology, as the parts we inspect, they have to be inspected at actually 68 degrees Fahrenheit. So it's a very clean environment, no heavy lifting. This program is designed for people who are really want a job where they can actually think a lot. Critical thinking skills is very important, but also the ability to program and inspect these parts. So if you look around through the room, large investments made in optical vision. We have machine tools that inspect the surface finish of parts, optical comparators. If you notice here on this particular plate, we have a part here that is made. So you see some of the actual tools that's used in manufacturing and metrology, gauges like that we would check the actual pitch diameter of threads, the fit of threads. So every machine feature that we make, we have to be able to inspect part quality. So this is basically a program that's designed for individuals to learn how to inspect highly precision parts.
Well, Troy, thanks again so much for giving our viewers a tour of the new Gene Haas Center for Integrated Machining here on the campus of the Institute for Advanced Learning and Research. What a wonderful partnership between Danville Community College and the Institute. Of course, DCC having their 2-year precision machining program that has been so successful over the years, and then adding that 3rd-year capstone program, which will be housed here at the Institute, utilizing a lot of the Haas automation machining that you just saw here at the Precision Machining Center. Named after Gene Haas, of course, his foundation, supporting this initiative along with the Danville Regional Foundation. Just a lot of great partners coming together to really make this a game changer for our region. As Troy mentioned, when it comes to economic development, this is really going to be a game changer. And we'll bring you back out in the fall once the students start up this 3rd-year program, let you talk to some of them. And of course, they'll be looking forward to graduating in the spring, heading out into the workforce, and with some high-paying jobs in precision machining from all the training they've received here at the Institute and Danville Community College. So that's going to wrap it up for this week. Until next week, have a great day.